Welcome back. This is the rest of Chapter 4, Lesson 2, the other forms of energy. So the key here tells us that forms of energy associated with particles of objects include nuclear energy, thermal energy, electrical energy, electromagnetic energy, and chemical energy. And the reason that they lump these together in the rest of the section is because you can't see the mechanics of this as easily as you can a ball hitting bowling pins. With mechanical energy, you can often see the whole object, transferring its energy, you pedaling your bike, you shooting the basketball. In these forms of energy, it's happening with the particles. And in this case, by particle, they mean the molecules or atoms. So you'd really have to zoom in on them or have a special, measuring tool to be able to get an idea of how much kinetic and potential energy are inside of the atoms and molecules themselves. Okay, so that's why they put these together in the rest of the section. The first one that they talk about is nuclear energy. This is a type of potential energy, and this is where the energy is stored in the nucleus of an atom. So this is about as small as you can get in the examples here. So there's two types of nuclear reactions that can release energy. There's nuclear fission with an I, and that's where you split the nucleus apart, and nuclear fusion, like fuse them together. This is where you put the nuclei together, or nucleuses. It's technically nuclei. The power plant picture in the background uses fission. It splits the atoms apart. It releases a lot of heat energy, and we use that to produce electricity. It boils water and produces steam and turns turbines, and that produces power for us. Nuclear fusion, where we're joining the atoms together. The sun is a good example of that. And the sun gives off heat and light and some other types of energy that we'll get to later on. But we mostly sense the heat and light from those reactions. On the next page, it talks about the other four types of energy. So thermal energy is the total kinetic and potential energy of the particles in an object. So let's say that you have a pot of water ready to make some macaroni and cheese, and it's just sitting in the pot. It's not very hot. You don't see a lot going on there. If you put a thermometer in there, the atoms and molecules are going to bump into the thermometer. They're going to transfer some of their energy in the process, and that helps the thermometer register how much motion is there. And when you see the temperature of something, that's really what you're looking at. You're taking a measurement of how much motion there is in the individual atoms and molecules. More motion means more thermal energy, so the temperature goes up. So if you boil the water, when you see a rolling boil, you don't see the individual atoms and molecules moving, but enough of them are moving that the surface of the water is in motion, and some of them are evaporating off the top. You can kind of get an idea that there's a lot more going on in that pot now. So the thermometer would go up. Same thing if they're slowing down, hardly moving, not transferring a lot of their energy to the thermometer, it's going to go down. So, go outside and look at the thermometer you have outside. Those molecules are not moving around very much this week with the temperature that we're experiencing. Electrical energy, when you think of anything that runs on electricity, it gives you examples of things that you plug in, like computers and lamps and that kind of thing. But also, here they've circled a cell phone. If it runs on batteries, it's using electrical energy that was stored in the batteries. So that's the electrons moving through the wires. It includes lightning in this case. Electromagnetic is light that we can see. It also includes many other types of energy like X-rays, microwaves. We'll talk more about this in the next book. And then we've touched on chemical energy before, food and batteries and gasoline.